Hey everybody, so this video is a continuation of a previous video, which is maximum subarray. So to give you some context, so we started solving an easy question of maximum subarray, which is returning max of contiguous subarray. So today, as a follow-up questions, we are going to do this one called maximum product subarray, which is slightly harder than the previous video, but it's really good problem as a follow-up, giving you more constraints and some rules. So let's do it. Okay, so problem is given that an integer array nums, we need to find contiguous non-empty subarray within the array that has the largest product and return the product. So as usual, we're gonna start with goal setting is the return max. We're gonna return the max of product of subarray. Okay. From nums. So what's a constraint? As usual, I will start with, is it sorted? Is it sorted, or does the input contain a duplicate? Do we have negative numbers? Excuse me. Do we have 0 or negative numbers in this case? What else? Constraints for, do we have it empty? Do we have empty input? So let's take a look at them one by one. So is it sorted? So do we benefit if the input is sorted? I think yes, because if it is already sorted, we just need to start from a positive integer. That's right. Which also lead me to a first idea is this sort and find starting index and return product of nums and return product of nums of start index to the later. But this will take of log n at least, because that's the lower bound of the sorting algorithm. So anyway, let's go back to constraint 1. Is it sorted? The answer is no. And constraint 2, does the input contains a duplicate? Does it matter actually? No, I don't think so. This is a product which doesn't depend on having duplicates. So we can just ignore this constraint 3. Ignore this. Constraint 3, do we have 0 or negative numbers? Actually, it does matter in this case. So 0 will make everything 0 that we want to avoid. So we want to care about this constraint 3. So do we have 0 negative numbers? Yes. Okay, so the last question is, do we have empty input? So constraint is given that length is bigger than 1. So we can say no. But length of nums of 1 is possible. So probably, I think I will create one edge case. If length of nums is 1, just return nums of 0, because we don't need to product anything. Okay, so let's start. So we already have idea 1, which is to start sorting and then find the starting index, which will require binary search, which is runtime of log n. So we can actually include, we can just say n log n, because n log n is larger than log n. So we can ignore log n binary search. What else? Idea 2. As we used the previous question, we had dynamic programming. So each dp1, dp of index I, we should take the maximum of previous dp I minus 1 times the current num, or if the number is bigger, then we can take it. Is this enough? But the tricky part of this question is that we have negative numbers. So in this example, so let's say we have -2, and then 3, and then -4. So if we just use this dpi, answer will simply return 3, because 3 is the biggest from the algorithm. But actually, if we multiply everything, so -2, 3 means 6, and then 6, -3 times -4 is 24. So actually, this is the answer is different from this algorithm. So we need to include dp track minimum, dp of min I minus 1 times num. And then we're gonna do the same actually. So dp of min of I equal taking a min of everything. So by keeping track of both the maximum and the minimum, when we have a negative number, we can actually multiply to the previous dp minimum and then turn into positive number. So that's the, I think this runtime is open because we only traverse n. So n means the length of nums. So I think I'm gonna go with this one because of n is faster than of log n. So let's do it. Okay, so I'm gonna first create n is length of nums, and then dp equals array times n, and then first number is nums of 0. Similarly, I'm gonna create dp of min. So now we can do a dp for I num in enumerate of nums. So I'm gonna just copy and paste. Okay. One thing we need to be careful is that we want to start from second index because we already know nums of 0. So we start the index from 1. Okay. So what we want to return is the product of subarray. So I think we need to declare answer, and and the declared answer is starting from nums of 0. And then, so if answer happen to be smaller than dp of I, and then we update nums, then we update answer. So at the end of loop, we just return answer. Okay, let's do the edge case first, which we only have one number. Good. And example 2, which we have two negative numbers. Great. So is this enough? Let's submit. Okay, so it seems working. So the code is working. So let's try if we can optimize. Can we even optimize this? So in the previous question, we have used previous as a way to replace dynamic programming. So let's try if we can replace previous to dp. Actually, I want to keep dp. So pre we call nums of 0. And then we keep pre. Actually, for comparison, let's keep it anyway. So instead of dp, pre equals max of pre times num, and let's keep dp min for now. And actually not. So pre-build max, we can create pre-build max and pre-build min. Pre-build max and then pre-build min, just to see if we can do it faster. So pre-build min times num and then num, and I'm gonna do the same for min. So I'm gonna take minimum for the previous min. Okay, can we do this? Let's see. So let's use example 1. Looks good. Okay, so I think we have problem of -4, -3, -2. Let's copy. It returns negative. It returns 72. And let's deep dive into why is it happening. Okay, so let's print out. Oh, yeah. So let's print out previous and minimum. Print. So previous max had been 12. Minimum was 32. This is weird. Previous minimum is 32. Yeah, so we need to compute the temp first. Okay, so we need to compute temp. So what's going on right now is that because we had previous max here, it goes to the computation of previous min as well. But we don't want that because we want to track previous max, which is I-1 index. So we avoid using previous max here. But instead, at the end of computation, we're gonna replace previous max equals to temp. So this way we can avoid. Yeah, see, this is great. So I'm gonna submit this because it looks pretty good and faster than using dynamic programming of arrays. Okay, so it's much better in terms of memory usage. Still, it's a little bit of slow compared to other submissions, but in theory, this is of n because we only traverse only one traverse for arrays. Okay, so that's the optimization and follow-up as a question of maximum product subarray. Yeah, thank you so much.